The procedure is rinse the burette with distilled water, then the solution given. For example, in our case, we are going to use 0.1 molar hydrochloric acid. To wash a burette, you have to close the tap. After closing the tap, fill it with distilled water. Then after filling it with distilled water, open the tap. Open the tap, let the water run. So that is how you are supposed to wash your burette. So you rinse it with the solution that we're using. For our case, we're going to use 0.1 molar HCl. We add it inside our burette. Then we open the tap. So that is how we clean the burette. Here is the setup for titration, and we have to close the tap before we add the solution that is supposed to be used. The solution that we're going to put inside the burette, as we are told by our procedure, is fill the burette with HCl up to the mark. So we are going to fill this burette with hydrochloric acid. Now we have filled the burette with HCl up to the mark. You can see it is at the 0 mark, and we read our readings at the bottom of the meniscus. Then after that, we are going to pipette 25 cubic centimeters of sodium hydroxide. Our sodium hydroxide is inside this beaker. We don't know its concentration, therefore it is our analyte for today. Our 0.1 molar HCl is our titrant because we know its concentration, and we're going to use it to determine the concentration of sodium hydroxide. We are going to pipette 25 ml of sodium hydroxide. So this is our sodium hydroxide and our pipette. For us to pipette, we need to press the pipette filler, and then after pressing it, we place it inside the solution so that it can pull the solution. When the solution is going to reach at the mark on the pipette, there, you remove it from the solution and transfer it into the conical flask. Then after that, the procedure tells us that we are going to add 2 drops of phenolphthalein. So these are the 2 drops of phenolphthalein, which is changing the solution to pink. Remember, this is phenolphthalein, and we are going to add HCl. HCl is an acid, hydrochloric acid, and this is sodium hydroxide, which is a base. This is a neutralization reaction whereby an acid reacts with a base to produce salt and water, and this salt being neutral, then the color is going to change from pink to colorless, and that is why we say that an indicator is used to determine the endpoint. For us to titrate, you have to take your conical flask on one hand, and the other hand is going to hold the tap. You open the tap slowly and let some drops of our HCl get into the solution while you are swallowing. The swelling continues as we wait for the solution to be changed to colorless. So the reaction is on progress, and the end point is going to be determined when we are going to see the. Now we continue our swirling as we wait for the solution to turn its color. And what you are seeing, it is starting to turn its color. Therefore, I decrease the amount of solution getting into my conical flask so that the endpoint is going to be met without skipping any solution. So finally, the solution has turned colorless, and this is the endpoint, and we are going to take our readings. So you can see the readings are 14.2. It is 14.2 cubic centimeters. Before you start a titration, it is advisable to write the initial burette reading. For our case, it was 0.0. There is no need for us to write the units because here we are told it is in cubic centimeters, and after doing our titration here, you are seeing that our reading was 14.2. For us to get the volume of the acid that was used, we subtract 14.2 minus 0.0, and therefore we get 14.2. Then we are told the next thing that we're supposed to do is to repeat the procedure 2 and 3 twice for experiment 2 and 3 respectively, recording our results in the table that is here. Another point to note, it is very advisable to write the readings of the pipette that we used. With us here, we have used a 25 ml pipette. So you write here 25 cubic centimeters. Now we are going to do experiment 2 and 3 as we fill our table here today. For experiment 2 and 3, we have been told that we're going to repeat only procedure 2. But before you do it, it is very advisable to clean your conical flask. And our cleaning, we just take some distilled water and put it inside the conical flask. Then we rinse it like that. So it is clean. Then the second procedure said that we pipette 25 cubic centimeters of sodium hydroxide. Remember, for us to pipette, you just place the pipette filler and let it to pull the sodium hydroxide slowly until it gets to the mark that is on the collar there. As it gets there, remove it from the solution and transfer it inside a conical flask. And then we know that after you have transferred, we are going to add 2 to 3 drops of phenolphthalein indicator. Our phenolphthalein indicator is here with us. Do not forget, it is going to turn to pink because this is a base. So we add our 2 drops. Then after adding our 2 drops, we are going to proceed to the second experiment. From the previous video, I have advised you to first write the initial burette readings always before you start your titration. Therefore, I want you to see the burette readings here. It is 15.0. Remember, we read at the bottom of the meniscus, that is 15.0. You're going to ask, why do we have 14.2 as our final burette reading, and yet here it is 15.2? Sometimes you can have a faulty burette, and therefore you should not make sure that all your results look alike. Just take the results as they are before or when you are going to start your experiment. So you can see we are going to start our experiment, and we have already placed our solution. And as usual, I have advised you that one hand holds the conical flask with the solution, another hand is going to hold the tap. You can see I'm swirling and I'm waiting for my color to change. And immediately the color starts to change, I decrease the amount of drops that I'm getting to my solution. And you can see the color is now finally changed to colorless, and that is the end point for our experiment. Therefore, we are going to take the readings. The readings that we have now are 29.1, and therefore we just have to subtract the final burette reading from the initial burette reading. So 29.1 minus 15.0 gives us 14.1. And then we are going to proceed to our third experiment, whereby we are repeating the very procedure which we are supposed to do. These are our readings up to this moment. You are seeing the consistency in our readings, which shows that the experiment is just but the same. But most of the time, you get that most of us, when you do experiment, the units are not looking alike. I normally ask some of my students, how can you repeat the very same thing, but you are having very different results? The burette has a maximum capacity of holding up to 50 ml of a given solution. And let us see our mathematics here. We have our last unit as 29.1, and the consistency is telling us that our third reading is going to be something like 14.1, 14.2 there. If you add 14 or 15 to 29, it gives us 45. So we can still proceed with the solution that we have inside our burette. But it is also good for us not to just suspect it. Therefore, we can refill our burette again with the remaining solution, that is 0.1 molar HCl. Now finally, I've added my solution up to the 0 mark. That means that my initial burette reading for this case is, wait, I told you, don't take the initial readings before you measure the solution which we are going to use as our analyte. And remember, our analyte for today is sodium hydroxide, which we were going to pipette 25 cubic centimeters, all 25 ml of this sodium hydroxide, and then we place it inside a conical flask. Then after placing it inside the conical flask, we were adding some 3 drops, 2 to 3 drops of phenolphthalein indicator, but for our case we're going to use 2 drops. You are seeing what is happening. We have our pink color. Then after getting the pink color, then the next thing that we are supposed to do is to place it on our setup. Immediately you place it on the setup, then you can take your initial reading, which is 0.0, and write it on your table, 0.0, as we do our third experiment. Our titration now is starting, whereby one hand is supposed to hold the conical flask, whereas the other is going to hold the tap. We all know that this is going to turn by close to 14. So I can just open my tap until it gets to 12. Then when it is going to get to the 12th mark, I'll start letting the solution to get into my beaker dropwise as I wait for the color change, so that I'm going to get the very exact readings that I'm expecting to get. So the color finally has changed, and we are going to take our readings. What you have seen, the readings are 14.1. We take our readings to our table. Remember, it is the final burette reading for the third experiment, which is 14.1. And finally, we realize that the volume of the HCl used is 14.1 minus 0.0, which gives us 14.1. And this is how we fill our table. You can see the accuracy that is met here. It is looking wonderful because we are repeating the same experiment. Therefore, when you are told to do this experiment, try your best to get the exact results by being consistent. Finally, we get to the calculations. The first question is calculate the average volume of HCl used. For us to calculate the average volume of HCl used, we use the values that we got here at the volume of HCl used, 14.2, 14.1 and 14.1, and we must consider this rule that the values must be within a range of plus or minus 0.2, whereby all the values are within that range. Therefore, we're going to use all of them. That is 14.2 plus 14.1 plus 14.1 divided by 3, which gives us 42.4 divided by 3, and therefore the average volume is 14.13, and the units of volume are cubic centimeters. So that is how we calculate the average volume. Then the next question is calculate the number of moles of HCl used. Now we have the volume, the average volume that we used, and from our question, when you read from the first procedure, is that we were using 0.1 molar HCl. And remember, this is the molarity, that is the concentration of HCl that is in 1,000 or contained in 1,000 cubic centimeters. But we managed to use 14.13 in our experiment. So if in 1,000 cubic centimeters is 0.1 molar, what about in 14.13? Therefore, it is 14.13 cubic centimeters times 0.1 molar divided by 1,000 cubic centimeters, whereby cubic centimeters are going to cancel, and our answer is going to be 0.0014 moles. So these are the number of moles of HCl that was used. Then the third question is to find the number of moles of sodium hydroxide that was used. For us to find the number of moles, let us get back to the question. As you can look at this question, we were pipetting 25 cubic centimeters of sodium hydroxide, but we were not told the concentration of this sodium hydroxide. Still, we know that we can write the equation of reaction so that we can see how many molecules of sodium hydroxide react with how many molecules of hydrochloric acid through our equation, whereby when you react sodium hydroxide with hydrochloric acid, which is dilute, you are going to obtain sodium chloride salt, and water, which is a liquid. Our equation is quite balanced. Therefore, we realize that the reaction ratio between sodium hydroxide and hydrochloric acid is 1:1. Therefore, the number of moles of HCl used are equal to the number of moles of sodium hydroxide that was used, which gives us that the number of moles of sodium hydroxide used also is 0.0014 moles. Then finally, the aim of this experiment is normally to calculate the concentration of that substance that we don't know its concentration, which is sodium hydroxide. So the question is, what is the concentration of sodium hydroxide used? From still the procedure, we know that we were using 25 cubic centimeters of sodium hydroxide, which gave us 0.0014 moles. So 25 cubic centimeters of sodium hydroxide that we used contained 0.014 moles. But when we calculate concentration, remember it is the amount of solid that is contained in 1 liter, whereby 1 liter is 1,000 cubic centimeters of a given solution. So we are going again to close multiply 1,000 cubic centimeters times 0.0014 mole divided by 25 cubic centimeters, whereby cubic centimeters are going to cancel one. There it goes to 1,040 times. So 40 times 0.0014 mole gives us a concentration of 0.056 molar. And that is how we do our calculation on direct titration. Thank you so much for following up with us. Until next time, when we're going to address another type of titration. Thank you. Bye.